Grade 10 Circuits, Electric Circuits from the November 2016 examination. The first question asks us to find the total resistance of the circuit. So the first thing we're going to do is we're going to go to the battery. That's always the best place to start. And the longer line here at the battery shows the positive terminal, and the shorter line signifies the negative terminal of the battery. And we know that the total current in the circuit starts off at the battery, and it would then flow through this ammeter. So this tells us that this ammeter measures total current. That's the total current as it leaves the battery, and they've given us that. They said it was 2 amperes. Now if you follow the path of this current, it would reach this point here, and here it would have an option and would split. So some of the current would go to the 6 ohm and some of the current would go to the 3 ohm resistor. And this is what shows us that the 6 ohm and the 3 ohm resistor are in parallel because of the split that occurs. The split is what shows us that we are dealing with a parallel circuit. If we continue this, we can see that ammeter A2 measures the current that comes out of the 6 ohm resistor, and ammeter A3 measures the current that comes out of the 3 ohm resistor. And then we can see that at this point, the current is back. The total current is now together again, and it is the total current that flows through the 4 ohm. So that tells us that the same 2 amperes, the total current, is what flows through the 4 ohm resistor, and then it returns back to the battery. So now if we want to answer the question, calculate the total resistance of the circuit, we would first need to calculate our total resistance in parallel. And we know that the equation is 1 over R parallel is equal to 1 over R1 plus 1 over R2. So 1 over R parallel is 1 over 6 plus 1 over 3. And when we solve for Rp, we would get an answer of 2 ohms. But they wanted the total resistance, and we know that the total resistance is made up of the resistance in parallel plus the resistance in series. So our parallel resistance is 2 and our series resistance is 4, which gives us 6 ohms as the total resistance of the circuit. Now, when we were looking at the circuit, we saw that it is the total current which flows through the 4 ohm resistor. And that is how we know that the 4 ohm resistor is a resistor that is connected in series, because it receives the total current in the circuit. They now want us to find the reading on ammeter, or rather the reading on V2. So if we go to V2, we can see that it is connected in parallel. All voltmeters are connected in parallel, and it is connected across the 4 ohm resistor. And we already know that 2 amperes of current flows through the 4 ohm resistor. So if we use the equation R is equal to V over I, and I substitute 4 as my resistance, and I'm looking for V2's reading, I would take the current that flows through the 4 ohm resistor, which was 2 amperes, and that gives me a voltage of 8 volts. So remember, earlier in the question, they told us that the reading on voltmeter V1 is 12, and because voltmeter V1 is connected across the battery, we know that this is the total voltage in the circuit, and this would be the voltage V2. And now we can actually find, if I've got to put a voltmeter across the 3 ohm resistor, and if I put a voltmeter across the 6 ohm resistor, remember they are connected in parallel, and we know that parallel voltages are the same. So the voltage across parallel components in a circuit is the same. And we also know that the total voltage is made up of the voltage that goes to series plus the voltage that goes to parallel. So from the 12 volts, we've already found out that 8 volts go to the series, and that leaves us with a parallel voltage of 4 volts. So this means that if I've got to mark my voltmeters, this voltmeter here would read 4, and this voltmeter would read 4. And if I connect a huge voltmeter or a larger voltmeter across both resistors, that would also read 4, because voltage in parallel is constant. So it is the same 4 from the 12 that goes to parallel. So from the total, some of the voltage goes to series and some of the voltage goes to parallel. So if my total was 12 and 8 goes to series, that left us with a parallel voltage of 4 volts. And now it would be easy for me to find the reading on ammeter A2. Ammeter A2 measures the current in the 6 ohm resistor. So I 6 ohm, current in the 6 ohm. So if I use R is equal to V over I, the resistance is 6. The voltage we calculated now across parallel was 4. And this would allow me now to find the current. And that gives me 4 over 6 or 2 over 3, which is 0.67 amperes. And that is the current in ammeter A2. Now they want the amount of charge that flows through ammeter A1 in 120 seconds. So if I go to the circuit ammeter A1, they want charge, which we know is Q. And they've given us time. They said it was 120 seconds. And we know the equation Q is equal to I delta T. The current is 2 and the time in seconds is 120. So that would give us 240 coulombs. Remember to convert the time to seconds if they give it to you in minutes or hours, because second is the SI unit. How will the reading on ammeter A1 be affected? Now, ammeter A1 we said is the total current if the 6 ohm resistor is removed. Increase, decrease, or remain the same, and explain your answer. So we know that if we remove a resistor from parallel, we can see the 6 ohm resistor is connected in parallel. If we remove it, as they say, then we have now removed a resistor from parallel. And removing a resistor from parallel, our total would increase. And we know that if the total resistance increases, then the total current would decrease. And the reason is because the resistance is inversely proportional to current when the voltage is constant. The total voltage in the circuit has not changed. And the total resistance increased, so therefore the total current would decrease. So this is how you would answer. And they asked us to say, would it increase, decrease, or remain the same? And ammeter A1, the total current we said would decrease. And our reason for 3 marks would be removing a resistor from parallel, R total increases, therefore I total decreases. According to the equation, R is inversely proportional to I when V is constant. I hope you found this video helpful. Please like if you did, subscribe so that you don't miss future videos, and share this video with your friends so that more learners can benefit from these videos.